Hello everyone, how are you doing? Sorry to bother your Friday, but you have an exam coming soon. So let's work on that together, okay? The first question I sent you, by the way, this video is going to be me solving this problem with you. So if you haven't solved it yet, or tried at least, please pause the video and try it. Like, seriously, do so. Because that's gonna help you solve other problems is either in the exam or anytime. If the more you make mistakes now, the less you're gonna make them later. That's what I believe. So try this out. Try this method, okay? Now back to our question. This question is about a student who found a rock, and this student wants to know what this rock is, like what is the matter that is made of this rock. And he has like a way to know that, which is if he knows the density, then he will figure out what type of rock is that. But how to know the density? This is the question. How would we be able to know the rock density? In class, if you remember, we talked about Archimedes' method, about the crown. So this is a little bit the same, part of it at least. If we want to know the density, we have to know something else. Rho is equal to mass over the volume, right? So we have to know the mass and we have to know the volume. This is all you have to do. First, let's talk about the mass. Just bring a scale and measure the mass. So this is what we have to do. Number one, by the way, let me tell you about this. This one has 6 marks. It means that you have to mention 6 main points. Well, I know that's easy for you to say, like, submerge it in water and you're gonna know everything. But this won't give you more than 1 or 2 marks. And this question is saying 6 marks. Means go there with details. Like, state every step that you're going to go through, okay? So number 1, we're gonna deal with the mass. So just bring a scale and let's write it that way. Use a scale to measure, I forgot an R. So the measure M. Number 2, now after we found M, we have a problem with V. If the volume of the rock was this is another way. If the shape of the rock was a little bit more regular, like uniformed or so, that would be an easy thing. Just gonna use a formula from math and it's gonna be solved. However, this rock, its shape is just not really easy for us to find using math. Pretty much we can't. So that's why we'll have to find another way to solve it, which is the Archimedes method. We're gonna bring a container or a can, let's call it a can, fill a can with water. This is number 1 until the very end of it, like until the edge. This is number 1, number 2 now. Number 3, what you gonna do? After you fill, you bring the can, you fill it with water. Now you will have to place your rock there or drop it there. Let's say place. Yep. Place the rock there in water. Why would we do that? Because we want to collect the displaced water. So place the rock in water and collect the displaced water. This is number 3. Until now you got 3 marks. So after we collect the water displaced, now we have to measure it, because we know that Archimedes' method is all about the displaced water is equal to the volume of the displaced water is equal to the volume of the rock. That's why we dropped it in that water in the first place. So we have to determine V, the volume, by, how can we do that? Of course, of the displaced water. By a measuring cylinder. Oh. Well, as I told you, if you remember, this is the only way we can know the volume of the water is just by place the water in a container that has a shape. We can use a mathematical form to solve it, like to find a shape. So just collect the water that's going to be displaced in a can or in a cylinder that has an easy to figure out shape or volume. Then this is number 4. Number 5, after we found the volume of the displaced water and we know the mass, before that, we're gonna say like that the volume of the rock is equal to what? Of the volume of displaced water. So let me redo that again so that you can follow up with me. First of all, we're gonna have a scale or a balance to find the mass. And with this, the problem is with the volume. The volume is irregular, so we have to find another way to find to figure out the volume, which is dropping it in a container or a can that has a lot, water until the edge, and then collect the displaced water and put it in a cylinder so that we can find the volume of this displaced water. And we know that the displaced water, the volume of displaced water is going to be the same as the volume of the rock, because that water was displaced because of the rock itself. And this is Archimedes' law, by the way. So now this is number 9. Number 6, I think you're gonna have a mark by just saying that you're gonna use V, the volume you just got, and M, the mass, in the first step to find or to calculate rho. And rho is equal to M over V. Voila. This is the end of the first way or first method, which is Archimedes' method. Seems a little bit complicated. You don't have to write it the same way I did, but this is the ideal answer, to be honest. But you can use your own words. You don't have to say it exactly how I said it, but use your own words to explain the whole process. Tamam? So this is the first way to solve it. There's another way, a little bit less detailed, but you're gonna get a full mark, I think, which is, I would love to call it Hussein's method, because Hussein in the class, he just mentioned that, I remember, which is correct. This is another way of solving it. And let me try, I'm not writing this down, try to remember with me, but so the first thing, you will have to measure the M again. This is, by the way, this is method number 2. So you're gonna measure M again using a scale or balance. Number 2, you're going to have a can or container again, but this time part fill it. Don't fill it till the edge. Part fill a measurement or a measuring cylinder. With water. Of course, we're gonna be using water all the time. So just part fill a measurement or measuring cylinder with water, and most importantly, measure V. This is the initial V. This is just the water inside the can. Number 2, you can guess now, we're gonna place the rock in that water. Place the rock in the water. And what? Now you're gonna measure the final volume, because when you're gonna put the rock in the cylinder in the water, then the level of water is going to be a little bit higher. So place the rock in the water and measure the new volume, which is, let's call it the final volume. What are you gonna do now? 3. If you want to have the volume of the the volume of the rock, all you have to do is the final volume minus the first or the initial volume, and then you're gonna have the V that we are trying to have in order to get the density. And again, you're gonna use yep, it's working. So again, you're gonna use M and V to find rho, and rho is equal to M over V. That's the first part. So you have 2 methods. You can use either of them. Both are correct. The first one is a little bit more detailed, but whatever suits you, just go with it. So here, the student determined the density of the rock. Now, he told you, like, now they know it. The density of the rock is known, which is this. It is 2.5 plus minus 0.10. What's the plus and minus? This shows you that the student is not 100% sure. Like, he's saying the density of the rock is between those two. He gave you a range. Tamam? And the question, by the way, guys, please, everyone, everyone, please read the whole question, then answer. Because sometimes they're asking about a very simple thing, very straightforward thing, and you're just gonna lose marks just because you did not pay attention to the question and not reading it all. So, yeah, what are the maximum and minimum values for the density of the rock? They gave us 2.55 plus minus 10. So the maximum is when you add 2.55, when you add the 0.10. This is the maximum. It's gonna be, all I have to do here is write. And the minimum, just subtract it. And it's gonna be 2.45. Why they're doing that? It's because they're not sure, not them, the student is not sure that the density is quite correct. Because this way is kind of a beginner's way to find out the density of the rock. And after you find it, by the way, how can you know what is the type of the matter made of, that the rock is made of? All you have to do is find out the density, then compare it with the density of different matters. And scientists have done the work for you. You will have a lot of, like a table with a lot of matters inside of them, showing you the density for each type, and you're just gonna compare. And this is what they did here, by the way. Just get rid of this part and this annoying dot, and now, yeah. So this table is showing you different type of rocks, and you're gonna choose which one, not one, which two. Pay attention to this. So you have to see which two of these shown in this table are a possible type of matter our rock is made of. And how can we know that? It's just by comparing the density. So we have it 2.55, and here we have different densities. Still, it's not clear how can we find it, right? So first of all, you have to find the maximum and the value, the minimum for those. And the same as you did here, you're gonna do here. So 2.9, and the range is going by 10 again. This is the maximum. The maximum is it's 3. So the maximum is 3, while the minimum is, yep, the minimum, forget this, the minimum is 2.8. As you can see, both of them, like this and that, our density is so out of this range. The maximum of our density is 2.65, while the minimum for basalt is 2.8. So basalt is out of question. Here's what you're gonna do now. You don't have to find out for all of these. Just come to the options here and see basalt. We know that this is cancelled because basalt is absolutely not, the density of our rock is absolutely out of the range of the basalt. Let's go for chalk. And let me erase this first. So chalk, again, we're gonna find out the maximum value and the minimum. So 2.35 plus 15, and then we're gonna subtract it. 5 and 5 there, we have another one here, and so this is, actually 5, and here we have 2. So yeah, that's a possible answer. You see, it has 2.5 as its density. This is the maximum, right? Yes. And we know that 2.5 is somewhere here. It is in the range of our rock, right? So this, the chalk, is a possible answer. So you're gonna go back here and see which of these options has chalk in it. And we can find this one. This one has a chalk. So pretty much this is the right answer. Now, if you want to be sure, that you have to see what are the other 2 options. Flint, we don't have a chalk in here, and we know that chalk is one of the 2 rocks, one of the 2 types of rocks that our rock possibly might be, right? So this is making our life easier. We know basalt is not an option, so we get rid of that part, or of that option, but we know that chalk is a possible matter, or a possible solution, or a possible option for us. So that's why I'm choosing this, even without going to the other 3 types. You got my point? This is a way you can use in order to decrease the time you're gonna spend on this question. So the correct answer, let's just clean things here. The correct answer is chalk and paint. You can make sure by adding the 0.1 here to make the flint, to make sure if the flint is, there is a cross section between those 2 or not, between the flint and our rock or not. But I know this is the right answer because chalk is only there, and here this one is out of question. So if there's anything you couldn't understand from my rapid explanation to this, please say so. So the last part of this question is asking you, the student only took one set of measurements to determine the density of the rock. Explain why taking the measurements more than once may improve the accuracy of the density value. So this is a question not only about the density, but generally when you do the experiment a couple of times, the results are going to be more accurate. And why is that? Because you are decreasing or reducing the the effect of something called random errors. For example, if you're gonna ask, I mean, don't do that, but if you ask me about my weight and I don't want to say it or I don't know it exactly because I haven't I haven't used the scale for the longest. So I'm gonna be saying something, hypothetically speaking, of course, this is not my weight, but let's say hypothetically speaking, is something between 50 and 55. So you want to make sure, like I'm giving you like, I'm saying like my weight or someone's weight is, yep, it's something like 53 minus plus minus 2 kilograms. This is the mass, but we're gonna go with the weight thing. I want to know what is exactly what is my weight or someone's weight. You have to, you don't do it just once, because if you do that, if you measure your weight once and you were wearing winter clothes, if you're gonna do that again in summer, it's not gonna be the same. And it's not because of your weight, it's because of the something out of يعني, not out of your control, but something that I didn't ask for. This is not your weight. So that's why you do it a couple of times, because when you do it a couple of times, you reduce the effect of these errors, because the weight of the clothes is not included, and it's sometimes it varies. So all you have to do is do it a couple of times to get something called the mean. Let me write another way. So why taking the measurements more than once may improve the accuracy of the density? Because then we can calculate the mean. I'm not sure if you know about the mean, but the mean is when you add the summation of the results you get from the different attempts of your experiment, and you divide them with their numbers. But yeah, if you don't know about the mean, ask me in the chat. But if you know, we're gonna go to the next one, because here it has 2 marks, so pretty much that's not a full answer. So they're asking for something else. Number 1, because we can calculate the mean. The mean is the closest to the real, for this case, for the real result, for the real density. But the number 2 is, number 2 here is to reduce. We can, why it's a good thing to do the experiment a couple of times, because there we can reduce the effect of random errors. And that's the end of this question. Man, that took so long. Sorry, guys.